Hello, all. I hope everyone is healthy and safe at home. I hope you're enjoying your winter break and what is now an extended winter break. Look forward to seeing everybody on Monday. I'm sure Mr. Kubowitz shares the same sentiments. Again, hope everybody is well. We are going to do a little something here, as we are required to do. Should give me, or I'd ask you to give me about 10 minutes of your time to get through this. It's just a little warm up, a little prep for what we're going to be jumping into when you guys return next Monday. At least hopefully return next Monday. As we dive into some geometry topics. So, what I would like you to do, there should be a document attached to that message on Skyward that you could open up. I've also put this on Canvas so that you would be able to go to Canvas and find the document as well as this video. So, with that said, again, look forward to seeing everybody on Monday. What I'm going to do right now is switch over to the document. And then once this is up, there we go. We'll go ahead and go through this. So if you have this printed, that would be fantastic. If you don't have a printer, just some scratch paper would be good. Just to make sure we kind of understand what we're doing. And then when we get together on Monday, we will just kind of move along and jump into some geometry here over these next couple of chapters, some of my favorite stuff. So here we go. So at the top here, you're going to just see it's kind of a 5.1 warm up. We won't dive too much into some of these topics that I'd prefer to have you in front of me when we initiate that stuff. So we'll just get you warmed up here, reintroduce some things that you should be somewhat familiar with. So as we move through those things and get to them, we'll have a working vocabulary already attached. So number one, I'm going to ask, what is the diameter of a circle? And then be specific by including what points of the circle it connects. And I'd like you to draw a picture. So in terms of what our definition of a diameter is, so that definition is a line segment with endpoints on the circle and the segment passes through the center of the circle. Okay, so I'll give you a minute to get that down. So again, a line segment whose endpoints are on the circle. That segment must also pass through the center of the circle. So let me write this a little bit better. It's the word center of that circle. Next thing I'd like you to do is draw a little picture of this. So let me draw in a circle here. What's up? So obviously we're talking circles in this case. All right, the endpoints are on the circle. It needs to pass through the center of that circle. So what I'm alluding to here, if I put a dot here, that's on the circle, a dot right here on the circle, and I connect these two. All right, that is a segment. So that's what I'm alluding to as a segment. It is a line that has a distinct starting point and a distinct ending point. We don't go any further left, don't go any further to the right. So by definition, or in terms of what the definition of a segment is, that's what we're talking about. The endpoints. Here's this endpoint, here's this endpoint. It lies on the circle. So we can obviously see the circle right here. We're lying on that circle. All right, so that's a segment with the endpoints on the circle. However, what I've also mentioned is that particular segment, in order for it to be a diameter, better go through the center of the circle. So if I say that this is the center of my circle, this segment does obviously go through, or I'm sorry, starts and ends on the circle, but it's not going through the circle. So this we would not consider a diameter. However, if I went ahead and used the same initial point and then now went through the center of the circle until I hit the circle down here, now I've satisfied everything. I have a segment whose endpoints are on the circle. So that's this guy to this guy. And that segment passes through the center of the circle right here. This is a diameter. Okay. All right. Radius of a circle is another line segment. So a line segment is a line that doesn't go on forever. It has a distinct starting point and a distinct ending point. So a line segment with one end point on the circle. So in the previous one, we said diameter, we said both endpoints are on the circle. In this case, we just want one endpoint to be on the circle and the other endpoint at the center of the circle. That is our definition in words. And then now let me draw in a quick little picture here. So again, just another line segment. Now we want one endpoint at the center of the circle, and we want the other endpoint on the circle. So that we would consider a radius. All right. Like the other one, I should have mentioned this earlier, there's a lot of these. I could have drawn in a diameter right here because this green one also has two endpoints on the circle, goes to the center. Same down here. I could draw a radius maybe from this center up here. That's a radius. Those are all different radii as long as we satisfy those two conditions. Okay. 3, a straight angle. An angle of 180 degrees is what a straight angle is. So write that down first. When I ask you to draw a picture, think about what, if it's a straight angle, an angle of 180 degrees, the reason it is called a straight angle is because a straight angle is basically creating a straight line. So whether that's a segment like we've been doing here, if I ask you what the degree measure of this angle is here, this whole angle in here, that's a, oops, let me turn off the, if I can, erase this. That whole angle from here to here is 180 degrees. So you're hopefully familiar with like a 90-degree angle. All right, in terms of this line meet to form a 90-degree angle. If you just have one continuous straight line right here, that angle is said to be 180 degrees. That's also referred to as a straight angle. Supplementary angles are two angles whose sum is 180 degrees. That's our definition. What I'm going to have you draw in, let me draw in a line here. All right, line segments. And then what I'm going to do is draw in another little thing here. Talk specifically what this thing would be called here in due time, but go ahead and split that up. So put a little dot right here and then say that this continues on upwards and to the right forever. We already know that this straight line right here has a 180-degree angle. So that would mean that these two angles right here, so we have an angle right here. We also have an angle right here. So let's call this angle 1. Let's call this big black angle here angle 2. Well, these two guys together, since if we were to add these and combine these, make this straight line, angle 1 and angle 2 are what we would call supplementary angles. Let me do one more and give you some numbers. Let's actually draw a line this time. So similar shape, straight line, pretend that's a straight line anyway. If I told you that this was a 110 degree angle, and we know the straight line here has to be 180, that would mean this smaller angle right here would have to be 70 degrees. These are supplementary angles because their sum is 180 degrees. Next one, complementary angles. Oops. Also deals with the idea of two angles. We're going to talk about their sum. In this case, complementary angles have a sum that is 90 degrees. So what I'd like you to draw in terms of the picture is draw in a 90 degree angle. So a 90 degree angle is kind of like the intersection of a road, all right, where kind of west meets north. Okay, that angle is always going to be a 90 degree angle right there. Well, if that's a 90 degree angle, also, as we start doing all these geometry topics, anytime you see me drawing a little square here, what that square is implying is that that's a 90 degree angle. Think back to kind of when you would have done rectangles and squares, things like that. In Math 1, we even did a little bit this year. The little square at that angle is implying that it's a 90 degree angle. So what I want you to now do, you might want to erase, don't necessarily need to erase, but if I now drew in another line extending from here, from that dot out, notice how that creates two different angles. I have this angle here, and I have this angle right here. I'm not giving you numbers in this particular problem. Maybe we'll do this here in a second. But the yellow angle and the blue angle together are supplementary because those together would give us this full 90 degree angle. So those are what we would call, did I just say supplementary? Complementary. Those are what we would call complementary angles. If we throw some numbers in here, let's say this was like a 30 degree angle, the blue angle, then this yellow angle, if the whole thing is 90, if these are supplementary, then this would have to be 60 degrees. All right, so those are complementary angles. All right, they add up to be 90 degrees. 6 and 7, really, the way we're going to name some of these things is going to be important as we move along. This says name the following angle in as many ways as possible. So what that's alluding to is we have this angle right here. Okay, when we have those two intersecting at point B, we create this here. So this is our angle. So there's really 4 different ways that we can name that blue shaded region, that angle that creates that blue shaded region. One of them is angle, let me turn this off here, angle 1. So if you kind of do this is the little angle notation. Anytime you see this guy here, it's almost like a greater than sign. A greater than sign would be like this. We're going to kind of draw it more so that the bottom of that is now horizontal. So this would be a less than sign. And then this would be our angle sign. All right, we try to draw this flat. That's angle. So we would say that's angle 1. Second way that we can name that is, let's say the 1 wasn't right here. This angle that we form all this blue shaded region is B. So we could say that's angle B. The third way that we can name this. So we've talked about those V's. One of the very last things we did last semester is we had these V graphs, and we talked about that point there, even with this one right here, this low point. We call this the vertex of our parabola. We called this point right here the vertex of the V. It's the same with this. Any angle has a vertex. All right, so this is the vertex of that angle. So when we name an angle, we could certainly just call it angle B because that's what that angle is. I could also, though, these letters are important. A, so the angle created from segment or point A to point B to point C, the way we would want to name that is exactly in that order, from A to B to C. So angle A, B, C means I start at A, I go to point B, I go to point C. Whatever I would have drawn in then creates an angle at B. The order in which we do this doesn't necessarily matter, as long as, notice right now, the vertex of this angle was B. Notice how the vertex, when I rewrote it, using the angle ABC notation, that the B is in the middle. I could have also have said that I started at point C, I went to point B, and then I went to point A. And if I did that route, I start at C, go to B, go to A. So I could also name this C, B, A. The important thing is, so we obviously change this order a little bit, but notice how the vertex is still in the middle. So when you see an angle named using 3 different letters, that middle variable is always the vertex of your angle. Okay? All right. And number 7, name the following segment in 2 different ways. So again, this is a segment. We wouldn't say this is a full line. A line would imply that this goes on forever. Okay, and obviously we're going to dive into that a little bit too. But you can see we don't have arrows on these. What we have is a line and we have 2 dots. So that's why we wouldn't call this just a line. This is what we would call a line segment. The way we're going to name this is we're going to say the line segment YZ. And the way that we show that this is a segment is over the top of this, you're going to actually put a little line segment. And that just means we have a starting point at Y, we have an ending point at Z, and we do not go any further. What we don't want to do is do YZ and put little arrows here, because that would imply that this goes on forever to the right, and then it would go on forever to the left. That's not what we're looking at. That's why we don't want to write that with a line over the top. We could also switch this order around and call it ZY, and that just means we went from this point to this point. So instead of going from Y to Z, that's what this one would imply. We could start at Z and go to Y. That's what this one would imply. And then again, put the little segment symbol above it, and then that would be segment ZY. Both of these name this diagram just a little bit differently. Now, there's a lot of stuff to this chapter, a lot of minutia, a lot of naming of angles, and then eventually we'll talk about the segments, rays, lines, a lot of ways that we can get confused here, a lot of different things that are going to be happening. So we really want to stay on top of this chapter. Again, hopefully you've had a good break. If you did have any questions, you're more than welcome to reach out. Wanted to keep this somewhat short. I think most of this you have seen in some capacity before, but I didn't want to do too much this first day while you're at home. So enjoy the rest of your day, and we will see all of you guys on Monday, hopefully. Have a good weekend.